Welcome to the talk. I know it's already your dry second day, last but one. Thanks for coming and welcome to the talk. Going to get it started. How many of you have heard of the word WebAuthn? Okay, so have crowd. Anything. Anyway, this is the 101. So I'm just going to talk about what is WebAuthn and stuff. The introduction. Okay, I'm Pradheepa. I'm a developer advocate at Okta, and authentication and authorization is my bread and butter. So if you have any questions on IAM or anything, you can reach out. Follow me on Twitter, and the website is not updated. Someone hacked mine. 4 or 5. So yeah, let's go to the agenda. I just want to talk into like what is the problem here solve with the WebAuthn, right? So why we need it, and then let's see what is WebAuthn, and then if at all if you are convinced why and what, then the next question is like how are you going to implement WebAuthn? So I'll take you through a simple demo, then see how the user experience looks like. I'll take some questions at the end. Get started. So WebAuthn means web authentication, the form of WebAuthn. So what comes to your mind when you say authentication? Username and password. Like that's the basic thing every day. So authentication means like for us username and password. What happens after that when you have created an account, right? A digital identity of the user is created. That this is fine. Everything is going good. What's the problem with that, right? Passwords. We know username is not sensitive, can share it across everybody, but the password. Every day we hear about like there is a data breach, password breach, that account is hacked, this account is hacked, and all those stuff. So why they are not secure? Because passwords are nothing but a shared credential. Create some credential and then you pass it along to some application, and you trust that application that stored, secured safely. And I still have seen someone who like whenever you reset a password, they will send you the actual password, not the reset link. I've come across the applications in such a way because they don't salt it. So that's a very high risk. Like imagine that application is like hacked. Your password is like it's in plain text. So that's a problem. And I think most of us are at least familiar with this. If you're 90, how many accounts? I took the screenshot yesterday. I'm sure that at least 1 or 2 accounts would have been added because you see like 12 billion accounts are already been hacked. Like you have the accounts. So whenever you see someone like you want to sound so geeky, you say like go to this website, give your email address, then show see you have all these accounts that have been hacked. Password. So that's one password problem. Let's say so I just put some statistics, but this is not the end of it. We have too many you see all the data breach report coming in, it has too many statistics. So just wanted to bring just two. One is like most of the data breach or whatever the threat that's happened, 80% of the time it's due to the password. So that's a lot. And in addition, if you see like in addition to, within this 80%, most of them are I'll also tell you why. And on an average, the users have around like 90 online accounts. That's common data. We'll have more eventually. But if you think about it, like you have 90 online accounts, are you going to have like 90 unique passwords? Going to remember? I'm sure it's not the case. You'll definitely use that. So what we found was 51% of the time the password. One statistics. I'm just going to take you through some very common problem of password. One is like, as I mentioned, we have 90 online accounts. What do we do? Use this very simple password so that we don't have to forget about it. Even now, as of 2023, the most commonly used passwords is password or QWERTY or 1 2 3 4 5 6 7 8. This is the this is very most common password. What's the problem with it? Easily guessable. Sometimes people use the same username and password, so it's easily guessable. So it's so vulnerable to brute force attacks or the dictionary attacks. So we as an IT provider, we come up with like say like, educate the user, and they say like, create a complex password, right? And the application will just prompt the educate the user saying that, we have a little tile that says, how weak or strong the password is. Then say like, use a special character, uppercase, increase the length. Everything is fine. Then what happens now? Either the user chose a very simple password, A1 password exclamatory, which is very easy to guess again, or someone, let's say we are, I'm going to be like use a very smart password, so let me use a password generator or something, or suggest a password. What happens is, I have successfully created the password. Now I will write it down. I'll use the same password. Yeah, this is what happens. So there is something called credential stuffing. Assume that you have like 90 online accounts, and one of the application gets hacked, right? The data is updated. What happens? The bad guy can just get the password, can try it in all the other accounts, and your sensitive data is compromised. Again, we came here, and then we saw like, okay, let's try to solve this problem. Use MFA. We use password. You use the push notification. We try to come up with a solution to solve this problem with MFA. I just want to iterate that any MFA is better than no MFA. So this is a given rule. But our MFA are like strong and secure, right? MFA has its own problem. It comes with its own problems. But what we also see is that the adaptability of MFA. It causes a lot of friction. People say like, no, I'm not going to use it. I'm sure you can answer to yourself like, how many of you have MFA in your Google account or Facebook account? Some common problem with the multi-factor authentication is like, I don't know, like sometimes we don't get the SMS, there is a delay. Sometimes there is a delay, so the password has already expired. You try it, then you give up. So people will not go for it. And the user experience, like the time to authenticate is increased. Like instead of username and password, you wait for someone to send the password, get it, and it's easily phishable. Yeah, one thing which I want to notice, like if the user has already trusted the UI, the fake UI with all the lookalike of your bank or insurance company, you're more likely to say yes to the or the notification. So it's easily phishable. So that's one part. And if you use the authenticator, the security depends on how secure your mobile is and how secure your app security. So again, there is another problem. What we thought about was like, okay, enough about password. We tried to solve the password problem, and then we thought like we don't want to find something else. Like we maintain the status quo, but it's not going to happen. So what do we do? If we put something else, then it creates a lot of. So we think about like, what about like replacing the password with something else, but without burdening the user, right? That sounds like a great idea, but let's see how it's been implemented. Okay, let's see what is WebAuthn. Okay, it's a global authentication standard. This is based on public key cryptography. If I deter you with any of the standards, don't worry, I'm just going to take a user journey. I have to say this because FIDO2 has taken a lot of effort. So it allows the servers to register and authenticate, using the public key cryptography instead of password. You're going to see how this is going to be like a better alternative. I'm going to give you a little overview, like this is the oversimplified version. You can also look up in what's in there if you want to know more about the details. So this WebAuthn is based on the digital signature. For example, let's say I have a message, and public key cryptography creates like a key pair. One is called a private key. As the name suggests, it should be private, and there is a public key. It can be public, it can be shared across all the applications. Even if you share it across the wire, doesn't matter. So what I will do is like, I keep a private key with myself, and then I send a message, and then I sign it with the private key, and that's a digitally signed. And someone who receives it, they can, if they have the public key, they can open it, but they can also verify that the person who sends it is the one who is the legit. So let's see how the verification happens. This is a signed message. I have a message, I have a signature. So I'm the sender, I'm going to sign it. The sender has the private key. So what it does is like, okay, the message to message is done. How does the signature part work? The signature part is like, I just pass my message through a hashing function, and I get some fixed length digest. So you have a digest message, then you pass the message to an encryption process. Since you already have the private key, it is not shared, it is not got at anybody. So you encrypt it with a private key, and then you create a signature. Okay, we all sent it. Everybody wants the public key, right? So how does the public key, the person who receives it, going to verify it? Okay, the message, he receives it, put into hash function, digest, message is the same, the digest is going to be the same. There is no, you have a different message, it's it's a zero probability that get a same hash digest for the message. And then I have the signature, I decrypt it with my public key. Then now I see whether these two messages are same. If it's equal, then someone who has sent the message, this message is not tampered, and someone who is sending the signature has the private key, right? So solve the problem of, we saw what's cryptography. This is what happening in the background. So we assume that you are sending a digital signature with a private key. Someone who is sending it can verify it with a public key. So how does the WebAuthn registration looks like? I'm just going to take through a user journey, and then we'll something like look at under the hood. So what's the registration look like? The user, they says like, hey, so the terminology is like, if you are any application, right? I'm using WebAuthn.me as a website. So it's called a relying party as per the 502 standard. User says like, hey, I'm Minu. I want to create a new account with you. Interesting. He's sending only the username, wanted to do the registration, no password. So now the application says like the relying party, okay, give me a public key. Okay, and let me think about it. And then the user creates the key pair, one public and private key, and then sends the public key over to the relying party. Now the key exchange is done, registration is complete. Okay, I know you have some question in my mind. I'll come back later. So the authentication, registration is completed. We have the keys exchanged. Now the user is returning. Then say, you know what? I'm the user. I've created it. I wanted to sign into my account. So the relying party says, okay, let me check. So the user has the public key associated with that particular user, right? So in order to verify whether the particular person is sending this message or something, remember we need to verify it. So the relying party has to send some random value. It's called a challenge. So it sends it over the challenge to the user and says like, sign it. That's how the relying party is going to verify the signature, like person is holding the private key or not. Okay, now the user signs message. Everything checks out. If the challenge that is being sent is matching with the signature, good. The user is verified. They are in. It's all done. Now to the bigger question. We talked about the users creating public and private key. Now password itself is complex. How is the user going to create it? We took the burden off, and then we say like, took the help of authenticators. So I have something called the YubiKey, just like this, which supports Bluetooth, NFC, or USB. So we are going to seek the help of these authenticators to create the signature. If you think like, oh, what if something happens to this device, right? What if I lose it? We have something called platform authenticators. Now our application is able to create some credentials and can be accessed via our biometric. So your key pair will be created by the API, the browser, and then it will be stored in your keychains. So obviously, if you store in the keychain, you have to access it via your user's presence. So either keep in, say Windows Hello, or the biometric. That's how you can access. So we have two formats. So there's some protocols behind it. I'll just give you an overview. One is like CTAP protocol, client to authenticator protocol. As the name suggests, client is your browser, authenticator is your YubiKey or your platform authenticator. The communication between these two, right, has to create a cryptography, two key pairs and stuff. So the communication is defined by this protocol. You can read about it in the 502 standards or WebAuthn.guide about it. So how this exchange should happen, this definition is already there. But as a developer, you don't have to worry about it, because the hardware or the platform itself will handle the communication. So if you're an application developer, you don't have to worry about implementing that part, unless you wanted to. There are some open source keys where you can build your own keys, and then if you want to explore it, you're welcome to. So that's one part. The second part is what the WebAuthn, which defines the communication between the server, the browser, and the relying party. So the browser has most of the latest browsers has the implementation for WebAuthn API. So the application developer just calls the API browser supported protocols like credentials.create or credentials.get, and then you get the credentials, and then okay. So I just piece everything together so that you'll get some picture. So we have three players. One is the authenticator, one is your browser, and one is the relying party or the application you're trying to access. So the authenticators can be internal and external, and the protocol is CTAP1 or CTAP2. There are two different versions, and you have a platform authenticator API, which I mentioned. It can be built inside your device. And if you're using a browser, the browser has to support the WebAuthn API. So on the relying party side, let's say you have a class server-side application over it, you should have a client-side JavaScript that should be able to call the browser API. So the registration and authentication happens via this. I'm not going to get into much detail about the attestation cluster, because that is more like how to identify the integrity of your authenticator. So you have some metadata service to identify it, or you can build your own store. So the server-side app will have the user store. This is where all your public key credentials, the user ID, and the credential ID are all managed. So this is the overall architecture. Now let's see the demo of how the registration ceremony looks like. So whether it works, so I just recorded a video. So there is a WebAuthn.me, which is a playground. So you can go here and then just play. So you say I'm going to do the registration process. So let's say I key in some username. So I have the user, password, going to do the registration. This is how the login box will look like. So if you look at it, I do the registration. So the browser sends a challenge. The relying party verifies the challenge. Now, so asking my device, like create a passkey. I want to show you this. There are multiple ways to create it. So either you can use a different device that has the credentials, or you can use a YubiKey, which can use it. I'm just going to try another way and continue. Now my Mac supports the fingerprint, so I'm just my fingerprint. Now if you see, there is a signature public ID sent to the relying party. So you have your user ID created, and you have public key section. So this is the whole flow, and your public key will be stored in your relying party. So let's look at the code. So these are all the players now. Like we have authenticators API, browser supporting WebAuthn API server. We'll see what's happening. This is the like what's happening in the exchange. So the user is sending the username to the relying party. Now the relying party says, like, okay, create the credential, create a public key, give me the public key, but I need to verify when you are sending it back. So I'm also sending my RP ID, which is called the relying party ID. This is an important factor which is introduced, because whenever there is an exchange happens, someone can intercept it and then change the message. But if you sign this message already, and if you open it, if the person who is sending it and the relying party ID is matches, then only the user can verify, the signature is not tampered, the message is not tampered. So we are actually solving 80% of the threats that's happening. with this method. So I'm sending this web RP ID, the origin, and also the challenge. Challenge is how I can verify the sender is they can send it with they can sign it the private key, so I can just see the public key. Sending it back. Now it's sending to the authenticator and says, hey, you know what? I have all this information. Create some public key and private key for me. Now the authenticator's job to verify the user's presence. So now it's asking for the user. If someone is asking to create the credential, so can I create the credentials? Can you just prove your presence? So I just touched the my Mac, or if you have your YubiKey, you can just touch your device by proving the user's presence. Now what happens? It creates a credential ID. It's important because if the same application, for example, the WebAuthn.me can have 4 or 5 there's any other number of authenticators. Like usually they advise you to have 2, like because you need a backup, something lost. So you can have like a platform authenticator, you can have your YubiKey, you can have any number of authenticators. So for each authenticator, the credential ID will be created, and the server will store it as an array. So whenever the user comes back, it just gives an array. So one of the authenticator, you just verify it, and then that's called credential ID. Attestation is something to do with your authenticator. So it creates an attestation object. So for example, let's say I am a banking application. I can just dictate like saying that the user should use only the YubiKey, or I can say like the user should use only the biometric. Those attestation information the relying party can expect. So it's sending some attestation object about like I am this authenticator, I have this information, can be verified, and I'm also signing the challenge. So everything is done. If there is no middleman in the attack, everything goes to the server. It gets all stored. So because the server can verify the origin, challenge, everything checks out. I can store all this. Registration is complete, done. So the user just keys the name. Everything is taken care by the platform. And now authentication, I'm not trusting you. So already the public key is created. There is a raw ID, which is your user ID. So I'm going to go next and then say authenticate. When you're going to authenticate, so you're just sending this information and then say sending the public key. And I'm going to say login. So now if you browser sends a username, then again raw ID and challenge comes back. Now it's asking me like you're saying you have an automatic credential, but the authenticator is trying to get my credentials stored. So I gave my user presence. Now the data has been exchanged. I'm verified. I'm logged in. And if you want to play more, you can just go to try the debugger. There are multiple options, like I mentioned, like attestation, what are all the signatures you can do, and all the stuff. Go and then try the debugger. There's also some information about what are all the things. So now the players. Same. It's just that going to retrieve the credentials that are being stored and then sending it back. Players are here. User is sending the name. Now the relying party has all this information, right? The credential ID is there. Sending the relying party ID to prevent phishing, and then challenge. Sends it back to the authenticator. Now sometimes it massages the data. So the client data is massaged in challenge and origin. The terminologies, but these are all the information we already know. So it sends to the authenticator. Now it just asks for the user's consent again, because someone is asking to get the credentials out of the authenticator. So user has to prove its presence. So it provides the consent to access the credentials that are stored in the authenticator. So it retrieves the private key and signs the data. If you hear something like an assertion or something, that's the data. That's the terminology, because we are asserting the user identifier. We build the data with signature. If there is someone in the middle, then we can always verify the origin, not tampered. So it's done. We can validate the signature. What we have seen is like the time to authenticate is half. Like in username and password and stuff, this is half. So I have some references that I have. The last one, I to creating a password list, was very useful for me because it answered most of the questions. So you can have a look at it.
Thank you, Pradheepa.